So let's look at an example to look at how these variabilities might impact each other. So here's an example of drugs and driving. So some antihistamines, like allergy medicines, make people feel drowsy, right, like Benadryl. One danger is that drowsy people are crappy drivers. To check whether an antihistamine makes people worse at driving, we wanted to test an antihistamine against a placebo, just a sugar pill, on people's driving performance in a video game. Well, here's like sort of the ideal case. In the ideal case, in order to determine whether antihistamines cause people to be like crappy drivers, one thing you might want to look at is, let's say, the score on the driving performance. So higher score means you're better at driving. Lower score means you had more like crashes or swerves or whatever it was, right? And so maybe we'll see, if we draw like a dot plot of the antihistamine people, right? Maybe we'll see them all having sort of, you know, low scores, right? Right? Maybe one guy gets a high score, right? But maybe the placebo group will just tend to all get sort of, most of them tend to get high scores, right? So if we had something like this, then we see that even though there's within treatment variability, right? So there's variability here, right? There's some within treatment variability here, and there's some within treatment variability here too, right? But basically the means are probably far apart enough where we could probably say, oh look, the antihistamines, they seem to be sort of different than the placebo group, right? And so that between treatment difference is still big enough that we could see it. But the world is not an ideal place, right? So sometimes, actually most of the time, we have a sort of noisy world because, you know, some people are just better at driving games, and some people are better at video games, and some people don't react to antihistamines as strongly as other people, right? So there's lots of places, lots of other variables that come into play for within treatment variability. And so maybe we might have, you know, differences, but okay? So maybe we have a lot of spread, right? So we have a whole lot of spread here, right? And among the placebo group, we might also have a whole lot of spread. Right? So in this case, it's sort of hard to see if there is a between treatment difference just because there's a lot of within treatment difference, right? And that's what we mean by it's sort of a bad kind of variability. It gets in our way of really being able to make conclusions from our experiment, right? And so what we want to do is reduce that within treatment variability as much as we possibly can. So to conclude that a treatment, some experimental treatment makes a big enough impact, what you really have to see is that the between treatment variability is greater, is overcoming the within treatment variability, right? So the between treatment variability has to come out strong, and the within treatment variability has to be sort of smaller, right? And so when we see that, then we could maybe start to have some more confidence in saying, hey, I think this treatment might make a difference.